Hello students, welcome to the classes. In this session, we will see MCQs on chemical kinetics. First question, which of the following is not true? Option A, molecularity may be whole number or fraction or zero. Molecularity can be obtained from balanced chemical equation. Molecularity may or may not be equals to order. None of these. See here, molecularity can be obtained from balanced chemical equation. This is true. Okay, this is true. Okay, molecularity may or may not be equals to order. This is also true. Why? Because order is different, molecularity is different. Molecularity tells you the number of reacting molecules which are taking part in the reaction, okay, or number of moles of reactant molecules which are taking part in the reaction. But order is nothing but the sum of powers of molar concentrations of reactants in the rate determining step. Okay, so order is different, molecularity is different. Okay, they may be equal, they may not be equal. That is true. So option B, molecularity can be obtained from balanced chemical equation. That is true. Molecularity tells you how many number of moles of reactant molecules are taking part in the reaction. So it's obviously obtained from balanced chemical reaction. But molecularity may be whole number or fraction or zero. Now this is wrong. Because why this is wrong? Molecularity tells you how many moles of or how many molecules of reactants or how many reactant molecules are taking part in the reaction. The number of reactant molecules taking part in the reaction cannot be fraction, right? So this is false. Now they have asked which of the following is not true? So option 1 is not true. So what's your answer then? Option A, molecularity may be whole number or fraction or zero. This is not true. Right, now let's see the second question. How order of reaction is calculated in the complex reactions? This is an interesting question. See option A, order is calculated from slowest step, B, fastest step, and C, average of orders of all the reactions is considered. See here in this case, what we do, see here. Let's take an example. Let's say there are 5 students. I have told these 5 students that you have to submit the assignment, okay, when all of you are done. You have to submit the assignment when all of you are done. So this means when you will submit, that depends on the person who is slow. See, the person who is fast, even if he writes it, even if he writes just within an hour, okay, if the person who is slow is taking 10 hours to write, you have to submit the assignment after 10 hours only, because I told you have to, all of you have to submit the assignment together. It means the total the total order, overall order depends on the person who is slow. So similarly, order is calculated from the slowest step, right? So which option? Option A, order is calculated from the slowest step. Right, now let's see the third question. Which of the following is not true again? Okay, see option A, rate constant is independent of initial concentration in first order reaction. Order of reaction is obtained from rate determining step. Decomposition of any substance on the surface of catalyst is a zero order reaction. Order in pseudo first order reaction is not 1. Okay, see here, the first option, rate constant is independent of initial concentration of first order reaction. See, the rate constant we represent using K. This depends only on temperature. This depends only on temperature. It is independent of initial concentration. This is true. They have asked which of the following is not true. The rate constant depends only on temperature, not on the initial concentration. So this is true. Option D, order of reaction is obtained from rate determining step. This is nothing but slowest step, as I told in the previous problem, right? The order depends on what? The slowest step. So this is true. So the second option is also true. The third option, decomposition of any substance on the surface of the catalyst is a zero order reaction. Now, why this is the case? Decomposition of any substance on the surface of catalyst is zero order reaction. This is true. Why this is true is, see, decomposition of any substance on a catalyst, on a surface of catalyst. See, if you take a catalyst, okay, it will have fixed number of active centers. Active centers means where the reactant molecules will occupy. I mean, the places where the reactant molecules sit on the catalyst, those places are called as active centers. Those are fixed. Okay, now if you increase the concentration of reactants also, okay, the number of active centers on catalyst will not change. Whether you have 10 reactant molecules, if you have what, for let's say 4 active centers here, if you have 10 reactant molecules also, only 4 will come and sit here. If you have 20 reactant molecules also, only 4 will come and sit here. Okay, the reactant molecules at a given time, the number of reactant molecules sitting in the catalyst, sitting on the catalyst is always the same. Okay, because the number of active centers on the surface of the catalyst is always same. So that is why decomposition of any substance on the surface of the catalyst, okay, it is independent. Okay, I can say this is independent of concentration of reactants. If it is independent of concentration of reactants, this means it's a zero order reaction, obviously, right? So option 3 is also true. Now option 4, order in pseudo first order reaction is not 1. Pseudo means what? False. See, false first order reaction. So order in the pseudo first order reaction is not 1. It looks like as if it is true, but this is not true. What is pseudo first order reaction? The reactions which look like as if they are higher order. The reactions which look like as if they are higher order, but in reality they are following what? The first order. Okay, they look like as if they are higher order, maybe second or third or fourth. Actually they are following what? The first order reaction. So such reactions are called as pseudo first order reaction. So in pseudo first order reaction, what's the actual order? Actual order is 1. So here they are telling not 1. So this means this is false. Okay, so they have asked which of the following is not true. So which is not true? Option D is your answer. Option D is not true. Right. Now let's see the fourth question. Which of the following is true? Lower the value of rate constant, faster is the reaction. Option A. See here, rate depends on what? Rate is given by K into concentration of reactants raised to N. Okay, N is order of reaction. Okay, now here if you increase the value of K, K is nothing but rate constant. If you increase K, obviously rate will also increase. It means the reaction will become faster. So here they are telling lower the value of rate constant, faster is reaction, which is false. So option A is not your answer, because I have asked which of the following is true. Now value of rate constant depends on initial concentration. Now this is also false. Why? I told you the rate constant value depends only on the temperature in the previous problem or previous question, right? So the rate constant depends only on temperature, not on the initial concentration. So option B is wrong. Value of rate constant depends only on the temperature. You can see here. So which option is correct? Option C, value of the rate constant depends only on the temperature. So option C. Now let's see the fifth question. Okay, in a first order reaction, okay, you can see 100 gram of sample, 50 gram is consumed in 10 days. In what time the remaining sample is reduced to 25 gram? Remember one thing, in first order reaction, half-life, what is meant by half-life? the time taken what to for the reactant molecules, the time taken for the reactant molecules to reduce to their half of the initial concentration. For example, here how much we have? 100 gram. Its half is what? 50 gram. In 100, 50 is consumed. How much we are left with? 50 we are left with. So we can see here it has become half. It has become half in how much time? 10 days. Right? In a first order reaction, half life doesn't depend on initial concentration, whether the initial concentration is, whether the initial mass, okay, maybe 100 gram, 50 gram, 30 gram, whatever it may be, okay, the time taken to reduce it to half is always same. See what they are telling, in first order reaction the remaining sample is reduced to 25 gram. It means remaining sample is 50 now, because 50 is consumed. Now 50, out of 50, 25 is consumed, I am left with 25. See, again it is becoming half. To become half, I told, okay, that is nothing but half life, and half life doesn't depend on this value, the initial concentration, whether it is 100 or whether it is 50. How much it is, I mean, is it becoming half of its initial value? Whatever the value may be, 100 or 50, is it becoming half of its initial value? Okay, yes, if it is becoming half of its initial value, okay, then it is always, I mean, the time always is same. So here for this also it just takes what? 10 days. Okay, so option A, 10 days. This is true only in case of what? First order reaction. Right, now let's see the sixth question. In which reaction the rate of reaction is not dependent on molar concentration of reactants? See, what they are telling is the rate of reaction, rate equals to K into, okay, reaction concentration raised to 0, because they are telling not dependent. It means we should not have this term at all. We should not have this term means the power has to be 0, right? Or for example, general form is what? Rate equals to K into R raised to N. R is molar concentration of reactant. So in the rate, okay, in the rate equation they are telling it is not dependent on concentration. It means you should not have this term. If you don't want to have this term, if you substitute this N value as 0, anything raised to 0 will become what? 1. So K into 1 will become what? K. Right. In that case you can see you have eliminated this value of R. Right. So this means in the zero order reaction the rate the rate value, or I can say the rate of the reaction, is independent of molar concentration of reactants. Whatever the concentration of reactants you have, rate does not depend on the initial concentration. Right. So which option? Option C. Okay, option C, zero order reaction. Right. Now that's the sixth question. Now let's see the seventh question. Which of the following is experimentally determined quantity? Order, molecularity, both A and B, none of these. See here, what is meant by experimental quantity? This means just by looking at the reaction, you cannot tell one of these two quantities, molecularity or order. Molecularity we can directly tell by looking at the reaction, because molecularity gives you what? The number of reactant molecules in the given balanced chemical equation. Right, it can be obtained from balanced chemical equation. Right, but order cannot be determined by looking at the reaction. Order depends on the rate determining step. Right, that is why, so order is experimentally determined quantity. Okay, we cannot just tell by looking at the reaction. Okay, so which option? Option A. Okay, this can be told just by looking at the reaction. Order can be calculated experimentally. Okay, we cannot just directly tell what is the order of reaction when we are given with any reaction. Okay, it has to be determined experimentally. Right, now that's the seventh question. Now let's see the next question. Now let's see the eighth question. SI unit of rate constant for first order reaction is? Now let me write the general formula for SI unit for rate constant, mole per liter raised to 1 minus n per second. This is the general formula. Okay, where n is order of reaction. Here they are telling first order. So this means mole per liter raised to 1 minus n is also 1 per second. 1 minus 1, 0. Right. So you get mole per liter raised to 0 per second. Anything raised to 0, 1. So leave this. Okay. So this term will go. How much you get? You get per second. So what's the answer? Per second, option B. Right. Now let's see the ninth question. Okay. So the question is, the rate of the reaction becomes 8 times when the concentration of the reactants is doubled. What is the order of the reaction? See, let's take the rate as R. That is nothing but K into rate constant into concentration of reactants raised to n. Now what they are telling is, see, this rate will become 8 times the initial rate R. When the concentration of reactants is doubled, it means R is becoming 2 times R raised to n. Now see here, 8R as it is, K as it is. Now this is 2 raised to n into R raised to n. Now see here, 8R equals to, I write 2 raised to n as it is, and K into R raised to n. K into R raised to n is nothing but what? R. So I will write R here. Okay. Now R and R get cancelled. 8 equals to 2 raised to n. Now how can I write 8? Can I write as 2 cube? 2 cube is nothing but 8. So this is nothing but 2 raised to n. If you compare on both sides, what's the value of n? N is nothing but what? N value is nothing but 3. So it means what? It is a third order reaction. Right. Now let's see the next question. The last question. Rate of reaction with respect to reactants is option A positive, negative, option B positive, option C can be positive or negative depending on the reaction, option D none of this. See, as the reaction proceeds, okay, as the reaction proceeds, the concentration of reactants decreases and the concentration of products increases, right? As the reaction proceeds, the concentration of reactants decreases because they are being consumed and the products are formed. It means the concentration of products increases. Here, as the concentration of reactants is decreasing, the rate of reaction with respect to reactants, we consider it negative, and the rate of reaction with respect to products, we consider it as what? Positive. Here they have asked with respect to reactants. So which option? Option A, negative.